Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. Today we're going to see another mesh analysis problem, and we're going to see how to solve this problem using matrix method. In previous video we have solved the same problem by using calculator and by using conventional solving method, whereas here we're going to see how to solve the same problem using matrix method, right? So if you have difficulty in writing equation, right, then you can use matrix method to solve the problems. So we will start the video with the same problem, right? So if the question is given like this, for mesh analysis, find the current in each resistor. I'm going to use the same circuit, right? So what is the first step you will do? You will find out the current across each mesh as same direction. So this will be I2 and this will be I1. And then you have to assign signs, positive and negative signs. So when you are approaching the resistor, it is plus and minus. And here it's plus and minus. And again it's plus and minus. Right? And I already explained you in previous video how to write the expressions, equations for any particular circuit, right? So if you don't understand how we are assigning plus and minus, and you don't understand how to write the equations, please go through the previous videos so that you can understand the basic procedures, right? And now we are not going to write any equation here. We are going to use matrix method to solve it. So what is the rules for matrix method? So this is the rule where the formula is you're going to use the same Ohm's law, V is equal to IR formula, right? But we are going to write this in matrix form. If you say matrix form, then for resistor, this is resistor, current and voltage. For resistor, it is number of mesh into number of mesh. If you take here this circuit, you have two mesh, right? First mesh and second mesh. So the R resistor will be 2 cross 2 matrix. It will be 2 cross 2 matrix. Number of mesh into number of mesh. That is why it is mentioned as R11, R12, R21, R22, right? So it is number of mesh into number of mesh, right? So it is 2 cross 2 matrix. Whereas the I and V, it will be only the number of mesh. It will be the number of mesh alone, number of mesh into 1, right? So if you see here, so it's I1 and I2. So it is I1 and I2, right? And it is I1 and V1 and V2, right? So here it is 2 cross 2 matrix, whereas here it's 1 cross 1, right? And now I want to understand here. Sorry, here it is 2 cross 1. 2 cross 1. Here it's 2 cross 1. It's number of mesh into 1, number of mesh into 1, right? And now how to write the expression for this, right? So uh, before explaining the procedures, I'll tell you how to write this particular matrix so that you can clearly understand, right? So if you take this element, it is a diagonal element. It is the diagonal element which is the sum of all the resistors of corresponding mesh, right? Whereas this is considered as off diagonal element. So this off diagonal element will always be negative because we are considering all the mesh in same direction. So we consider all the off diagonal elements as minus. As simple as that, right? Or else you will understand that if it is same current, if it's in same direction, then you have to put plus. If it is in different direction, you have to put minus. It will be confusing. So understand that off diagonal elements always minus because we are considering all the mesh in the same direction, right? So now how will I write this expression? Listen very carefully here. So it is first one is R11. So this is R11, right? This is first mesh R11. So this is first mesh and this is second mesh. Consider only this mesh alone. R11 is sum of all the resistors in the mesh 1. So it is 5 plus 2, 7. Right? And then R12. What is R12? What is the resistor that is common for mesh 1 and 2? Right? And this it is 2. Right? So it is 2. And since it is off diagonal element, it is always minus. Right? And similarly, here R21 is same. That is the resistor which is common for both the mesh, that is 2, right? So it is off diagonal element, so I'm putting at minus, right? And what is R22? R22 is nothing but sum of resistor in mesh 2, right? So in sum of resistor, it is 10 plus 2, so it will be 12. It will be 12. Don't worry about plus and minus sign, right? So you can write directly the matrix method, right? And now I1 and I2. I1 I2 is what we have to find it out. I1 and I2, right? And V1 V2 we have to find out. We got this given. What is V1? It is for first mesh. So while writing V1 V2, you got to be very careful here. Whenever there is a raise in potential, it will be plus. You can see here from minus to plus. This is how we approach, right? So it will be 10 plus 10 minus to plus, from lower potential to higher potential, right? That is voltage rise. And whereas here we approach in this format, right? Current flows in this direction. So we approach this direction. So which means from positive to negative, that is from higher potential to lower potential. So it will be minus 50. And now you can write the expression. Now you can write the equation. What is that? 7 I1 minus 2 I2 equal to 10. Similarly, minus 2 I1 plus 12 I2 equal to minus 50. This is equation. From this equation, you can able to solve and find out what is I1 and I2. Correct? So whatever I said here, that is what I've given a slide here. So you can see here R1 and R2 are the diagonal elements. It is always positive mostly, right? And off diagonal elements, if both currents are in the same direction, it will be positive. If the current are in opposite direction, then it will be negative. Don't get confused. We are considering all the mesh as clockwise direction. So it will be always negative, right? So this is what the same equation which we have obtained, and you can clarify this 7 minus 2 minus 2 12, right? So you can see here 7 minus 2 minus 2 12, and this is plus and minus 50, right? So you have obtained the equation. Now from this equation, you know how to solve it. You can use calculator or you can use manual calculation, and you can able to find out what is I1 and I2. So if you find out I1 and I2, I1 is 0.25 and I2 is minus 4.125. So we have to neglect the minus sign because we are assuming everything in clockwise direction, right? So we are neglecting that minus sign. So it is I1 and I2, right? So if you want to find out the current across each resistor, this resistor 5 is the same. I1 current is flowing here, and here it's I2 current is flowing here. Whereas here in this resistor, it is I1 plus I2. That's both current. So it will be 0.25 plus 4.125. So it will be 4.375, right? So don't get confused here. If you don't, what we are doing here is, even though we are getting negative sign, we are neglecting it because we are assuming normally everything is in clockwise direction, but actually here the current flows in this direction, right? So we are neglecting the minus sign here, and you are considering positive, right? And that is why you are adding plus, and we are adding this I1 and I2, right? If you don't understand this, if it is confusing, no problem. What you have done is, you have always taken 2 I1 minus I2, right? That is what you have taken, right? Always when you written. So which means I1 minus I2. That is what you are considering here. So even if you consider that way, no problem. I1 is 0.25 and I2 is minus 4.125. So obviously what it will become is, it will become addition. 0.25 plus 4.125, which is 4.375. It will be the same answer, right? So if you feel it difficult here, you can follow the same thing, right? But when writing the answer, you have to write it this way, right? So the current across this 5 amp is 0.25, whereas the current across this 10 amp is 4.125, whereas the current across 2 ohm is 4.375, right? So today what we have seen is we have seen a very interesting problem using matrix method for mesh analysis. I believe this video will be useful for you. Thank you, my dear students.